Welcome to everybody who's attending this webinar series, Top AI Tools for DevOps and Software Development. And in this episode, we're talking about building AI on your own terms, insights from Eficode's AI Agent Factory. So we're going to talk a little bit about what we've been building internally, and what kind of demo environments we've been doing about the whole AI Factory concept, and talking about what's actually going on around that. Hi, my name is Heri Terho, and with me I have Alex here as well from Eficode.
Hello.
And what's on today's agenda? We have a little bit of slideware, as that's what consultants do. I'm going to run you through a little bit of the background on what even does an AI factory mean, what's actually happening there, and then Alex is going to show a little bit of a demo on maybe not after you get all the definitions right, maybe not a 100% true AI factory, but pretty close to what we've been building on there to actually build up those software factories using AI. And then at the end, we reserve some time for questions. It would be good to put the first poll out to get some nice feedback from the audience. I just want a little bit of scope on what you guys are thinking about. What have you done with AI in your company or in your context? So I know a little bit about what I want to talk to you. Most people seem to be still planning, yeah. And using tools is currently the leader candidate in here. And then a little bit of a distribution on all the other fronts that we have in here. So mostly we have people, and I think this is quite a typical distribution of people. And when we're talking about AI, that some are still planning on using it. Most people are using tools like ChatGPT, Copilot, a lot of the other branded tools to already engage with AI. And I think that's now commonplace in everywhere, and it should be using these tools. Then we have some people who are already going into the custom assistants and custom agents part. And that's a little bit of what we're going to discuss. And I'm kind of, I don't know if I'm glad, but agent frameworks or agents using agents framework is the kind of like thing that we are talking about today. We are talking about the end level of how we want to build hybrid AI and human interactions in an organization. How do we want to build that? Okay. So I'm going to talk about a little bit about the context so that everybody gets on the same page. So mostly when we're talking about AI, we are talking about in many contexts, people are talking about that is the biggest opportunity now. It's going to change everything. Everything is going to be so great. And then in the reality, not many people are actually yet getting it into production, and there are multiple reasons for that. I see the opportunity pretty much, and that it will change stuff for about 60% of software teams using AI. I see significant productivity gains. I believe that 100%. I myself am also doing a PhD on software engineering and how do you do software core products and how your software architecture actually affects your business. And because of the way that you can use AI to change that, I see a lot of productivity gains in there as well. And exactly the truth has been that there is many amounts of data nowadays that shows that AI tools actually help people deploy faster. But then the problem is also that many companies are not fully prepared, and integrating that AI into existing workflows is harder than expected. And this is the kind of like part that we've encountered a lot in Eficode. And the sad thing that it pretty much comes down to basic DevOps. You have to have all of your metrics in place. You have to have some automation frameworks in place. You have to have access to data and all of that to actually do AI. So you first have to do DevOps, and then you can jump onto the AI train. But there are some low-hanging fruits that you can do as well. Oh, and by the way, I was reminded that please, if you have any questions, you can use the chat. You can ask me, just use the chat and ask at any point if you have anything that I'm kind of glancing over you want to hear a little bit more about, or then put some questions on the Q&A to answer them at the end of the whole presentation. So this is what I was talking about when I was talking about the five phases. They were named a little bit differently in the poll because of easier understanding. But basically what I'm talking about is many companies now are going through this 5-step ladder. And I think it's a ladder that you have to first just figure out the tool usage on the phase 1. Just get AI tools into developer productivity when you do software. You take those copilots, you take those low-hanging fruits, you take those tools off the shelf and start using them. Next up, I'm kind of like mashing together software agents and assistants, because assistants are what I call static in the sense that they cannot operate independently. They only operate from a human trigger, and that's what triggers them to do something. And an agent can work on any kind of other trigger as well, be it another agent or be it an environmental trigger or be it a build order or something like that. So that's the kind of definition that I'm using between assistants and agents here. And I'm mashing them all up now together to software agents that then do single agent workflows. For example, check this code, do code review for this bit of code, do this single thing for me. And the next part is that we are going to talk a lot more about is AI orchestrated workflows, how AI actually triggers other pieces of AI as part of your software lifecycle and your software whole cycle. Phase 4 takes all of your business requirements and start integrating that into your whole business. And how do you run your software development team? The integration goes much deeper than just inside of your software team. And this is probably going to be the most difficult part in your organizational culture to do, because you have to go into marketing data, you have to go into all of these other places that then feed into your software prioritization and all that to do it. And phase 5 is pretty much, I haven't seen pretty much any companies working on phase 4 or phase 5. And I'd gladly hear if somebody already has a company that works like this, that basically AI is integrated into all steps. AI can do autonomous decisions on phase 5. It can do business experience and can do that. We are not there yet. We are somewhere between, in many companies you are in phase 1, phase 2, and our demo is mostly talking about phase 4 and phase 3, 3.5 is what we're going to demo on the software factory front, on how do we actually get to the whole AI native in software business and thinking, which is the dangerous word here as well. And it's, as I said, it's mostly about fear of how do you get people do. The AI will replace development. No, it won't. It will empower them, give them a lot of more power to do. The same thing in software workflows. Who owns it? Who controls it? This is an important step, that we have to have a human controlling all of that to actually scale, because scaling is difficult, because it's all about how do you manage complexity so that you actually can make the AI behave as an asset, not a risk. The second one is as well, can I trust AI in coding? That's why you use a lot of these different normal day-to-day operation styles. For example, in coding, why do we have code review? Why do we have tests? Why do we have acceptance tests? Because you cannot trust the developer. You cannot trust anybody here. So that trust is a little bit of a strong word. But you basically have all of these methods to already build that trust in. So you just basically integrate your AI into the same workflow that you already have, with the same tools as you integrate a new team member. It's the same way that you integrate a new feature into your development. Just integrate in the same workflow. And Alex is going to demo a little bit of that and how do we actually do that in Jira. We've actually done something horrible that just made Jira into a software development tool, but you'll see more about that. And the fun thing is that the last lack of business case is something that we've heard a lot as well about. Why are we not taking AI into this? Because our company does not see it being profitable, because we do not see how it boosts us. And that's something that this just talks about us, because I stole our marketing slides for this. But basically it says that you have to look at the roadmap and how integrated all of that, because AI is a booster in pretty much all stages of software development that you can use. In all stages where you're using knowledge that can be replicated in some way, that should be replicated in some way, you can use that for long-term success. And this is pretty much outlining the same phases that we have. I'm not going to dive deep into that, but I just want to highlight the fact that we see in all of these steps huge coefficients for more efficient business that's going to happen. And you start from all the tools and you progress through the whole all of the 5 steps that we have here, and you're going to end up in some place that is going to be superbly more efficient in building it, and also like how to do it. And this is then the question of what kind of tools and what do you do to actually get to the phase 5 or phase 4, because even phase 4 or even phase 3 is going to be a huge leap in many kind of phases. And this comes back to agile principles or other principles, that there are basically 2 ways to manage complexity and 2 ways to scale, because that's what scaling is. You build your company to be bigger and bigger and bigger, so you accept more and more complexity into your company and into your process. So how do you then manage this and basically make that scaling profitable? You can scale in a way that makes you unprofitable and then go gloriously bankrupt. But you can. The ways to do this is great ways to manage complexity. So adding control structures, adding quality gates, and adding all of that around your complexity, or getting rid of that complexity by simplifying processes and streamlining all the stuff. You probably heard this from management consultants many steps. But these 2 things are key in AI integration into your culture, not just building the actual tools, but how do you integrate the AI into your company? Using AI to manage ways to manage complexity, or using AI to get rid of complexity, doing refactoring or doing systems that can go around that. And here's an example. This is what typically when we talk about software development, we typically talk about, hey, we do coding, we do coding. That's the thing. That's where the value is done. But that doesn't really happen. It's actually, if you zoom in on that left, there's two tickets that says check out from version control and developer does a commit. It's basically a manual step nowadays, and it's been a long time. That's what's happening. But if you look at the whole value stream, there's a lot of other stuff that not just the code generation, it's not just the testing or something like that. It's many of the value stream steps happen outside of the developer doing tests. And all of just the small part of that's been typically said as the value creation happens when the code is done. But actually getting sure that what should be coded, are we coding the right thing? Are we doing, sorry about that. Are we doing the right thing? Did we actually do the right thing? Can we verify that it is actually performing the way that we do? And how did we actually get it to the front of the customer to actually use it? These are all parts of the whole value stream that can be seen. And this is where the kind of like AI can be used in many of these steps to build your software factory. It's not just about Copilot writing code, but it's about the first step, basically getting the first points of data. When you get something from your customer, for example, a customer request, you can get it from a call center, transcribing and integrating that into R&D. An AI system automatically transcribes those phone calls, automatically takes them up, and then puts them to the R&D backlog, for example. This is then goes into requirement specification management, where we look into what should we actually do, choose some of them, and then do a lot of like adding additional information to those tickets to make sure that we are doing the right thing. And this is where pretty much we start our demo from in getting that done. The third balloon, which has 3 dots, and it's basically the old style of just automating the code generation, just doing GitHub, just doing all of those tools to help you to code. The second step, automates the note generation, for example, automatically generating release notes from what has changed in code, what have your tickets IDs been, and all this. There's been, let's say, normal methods for this auto generation as well, just taking the headers of your Jira tickets that were closed, for example. But typically, if you know how tickets work, that doesn't really map out to the actual features, but then enhancing that with an LLM who actually reads those, creates those change logs, for example, would be much better. And then when you're actually operating it, have an AI check what's actually happening in the logs, make up alerts and make up audit reports and acceptance tests with protocol, for example, to just generate a lot of these other steps in software development pipeline. Basically, what we want to build is we want to build an AI system from simple basics. This is probably the most basic system. And again, stepping up the ladder to lead you to the AI factory is how do you do proper prompts that you feed into LLM to get result? The basic agent workflow or assistant workflow that, hey, I want you to do thing X. Please do it in this and this way and give me the result. This is what you get. And we can, for example, use this very basic strategy to just generate tests for getting backups or getting Gherkin specifications, for example, for testing. But by itself, if it's not integrated into your whole work stream on what you're doing, and what's your context on this? Typically, these are quite useless. So what you want to do is you have some kind of memory and feedback loops in here. So the most basic version of this would be you can generate those tests, a human checks that they are okay, you save them into the repo, and then you have those as part of your whole repository to feed it back into the LLM. This is basically already building memory into your test cases on what your software should be doing. And we can augment that then with many other ways. And this is where we start delving more and more into this whole AI factor and using multiple agents to do this. And we start adding RAG, so best real assist generation. We start adding more and more context and more layers for the LLM to work with. We have some kind of knowledge base that runs a database that has the data in it. This database, in our case, should be any kind of data about your product, about your clients, about the needs, what's actually going on in there, and how do you integrate that into the LLM to provide you answers from your context and not just the basic general level context that you get from a basic LLM. And this is why I think these custom agents and custom assistants are very important, because you give them your context and give your context priority over general knowledge. And one that then is very important in this space then, is when you do this, you have to add guardrails into it. And when we're talking about software development, this is pretty much testing and validation. You could even say that the first bubble should be unit tests and the second one being acceptance tests on what we get. And those form the core basis of memory and guardrails for your system, so that you can build up these AI factories to automatically conform to these guardrails and to these limits that you are actually building. And this enables us to do very rapid development on new features or new development bases that we have. And that's pretty much the core of what we want to talk to you today. For example, I'm just showing you an example of a step or agent that we could add into the workflow is that you could have a security test professional with context like, hey, can you give me some kind of instructions to use known CVs to attempt this kind of stuff, and add this into your workflow. Hey, can a security test professional check my ticket, comment on it, what is actually dangerous in it, and should we do something about it? And then you get that to the ticket in the same as a human security professional could maybe comment on that, and you build up this stack of knowledge that you can then use. And this is the thing that in the last phase, you can start adding a lot of tools now into these AI systems with MCP servers and others to bring up that context from outside of your space as well. We actually did our demos before MCP, but basically building on the same kind of idea that MCP does. MCP still has problems like it doesn't really do security, it doesn't really do authentication, and it can allow for a lot of nasty things like remote code execution. But there are other frameworks that you have to build on top of it to do that security, to do the access control, to get it working. But it will open up the world. There's multiple different, everybody's not building an MCP server in their application, and that's actually one of the problems, that you're going to have hundreds of different MCP servers and running different versions, running different stuff, so it's going to be a management nightmare. So that's why I'm expecting that there's going to be something else to replace MCP or some higher level MCP like Kubernetes came in to control Docker, for example. And that's what we've been building around the whole system and how do we run our agents. And this is, as I said, pre-MCP, but we are now also integrating MCP into it. But basically the idea being that we can run AI agents in any platform, or it's just compute. It's basically you anyway want to run your agents where your data is, because moving all of that, your context is going to be difficult, it's going to be painful. I don't think you really want to introduce new places where you want to copy all of the data. You want to run that wherever your data is, build on top of that, be it Azure, AWS, cloud, or even locally with NVIDIA and NVIDIA and NVIDIA partner as well. So been playing around with that. And then have a central AI broker and a management software, as I said, like Kubernetes, to manage all of those agents, which you can then build on top of all of these different agents that we're going to soon demo: assessment, advisory, creation and onboarding, evaluation, monitoring, a lot of different phases that we can do, which then work on your data in the multiple different data sources that you have. And this brings us pretty much into demo time. So it's not just me showing you nice cogs from slides, but we actually have Alex here who's going to actually demo something that we had built, which I think is quite cool on what AI can do for you in for example, Jira. Go ahead, Alex.
Thank you, Henry. And thank you, Henry, so far for the presentation. All right, let's go to the demo. But before we actually start it, I want to show you some background information before, so that you can follow better the demonstration here. So let's go to this Bookspeed Solutions, which is our fictional company, and it is providing book database services. And in the background, it has more specific vision and strategy defined, and the service is in the early development phase, so that we are going to demonstrate how to put more features into this service with the help of our agents, right? And we have defined the development process here and technologies, and which this includes especially definition of ready, so that the agents as well as humans know what needs to be included into the specifications. And definition of done is probably familiar to everybody. And okay, this is something that needs to be done for the tasks in order to be complete, so that the agents know what it has to be executing, right? And then we have defined the technology stack and architecture, so that, for example, our architects can understand and take those things into consideration. And all of this is managed in task management, which is in our case Atlassian Jira. This is kind of a collaborative hub for AI agents and human team members to achieve common goals. I like the idea that we kind of can manage the whole software development with this single task management, and both humans and AI are working on top of that. Yeah, and actors that we have in this demo, of course, there's me. I will be presenting a new feature for the team to be developed, and I will be reviewing how the things go and probably need to edit some tasks if needed. And then we have a lot of agents going on here. You have a product owner agent who will write specifications for us. And then we have a data protection officer agent. And this will include the security requirements for the specification. And then we have architects. Software architect will kind of produce the implementation specification. Yeah. And then test architect agent will write test plan and write acceptance tests. And finally, we have developer agent, and software development agent will do the coding of the feature and unit testing, and test developer will implement the acceptance tests. And the final outcome is, in the end, collaboration of the people and the AI agent. In a perfect situation, we could achieve success rate with good success rate with only using AI agents, but in reality and in near future, I would expect we need people a lot here to be involved. So this is not no-code development platform yet, and we probably don't have. We won't see probably that very soon. Yeah, about my Jira workflow. Here on the left side, we have an explore column. This is the place or column where I will present my feature idea. And then some agents, product owner and data protection officer will do their magic, which I will present. Then I will review how it goes and eventually move the ticket to the next column, which is selected for development. Then our architects gigs are triggered so that the software architect will do the implementation specification and test architect will do the test design. And this is all the phase after which we can check what's going on with the AI. And finally, when we are happy with it, we move the tickets forward and our developer agents will do the job. We can do this kind of feature development and the testing implementation parallel, which is nice thing. And hopefully when we get something out, we can release this. Yeah, right. Okay, but let's go to the real Jira board. Okay. There we have explore, selected for development, in design, and so on columns. You are probably familiar with these. I want to do something like the service does not yet have books cover pictures. So I want to include books to have a cover picture. And I will use user stories to describe my need here. I will copy paste it in order to save some time. So as an administrator for the service, I want to upload book cover images for the book so that the service can be visually more appealing. Okay, I'm pretty happy with it. I can be not so precise here, and AI can actually help me with my user story creation. If I write here something like nonsense, I will get user story template instructions for me and so on. So these kind of agents can help us a lot, even defining user stories in the early phase, right? Okay, I will create this now. So now it's created. And within this board, I have two ways to trigger agents. One is implicitly and one is explicitly. And I want to trigger the agent here now. Hopefully it works. Yeah, right. I can choose here actions and trigger requirement to specification agent, which is a synonym for our product owner. So I will use that, and pretty soon I should get a pretty good definition of ready template and filled in information. What is wanted here? Okay, we have purpose section here, acceptance criteria, and some non-successful cases as well, and replacing existing book cover. And then dependencies, design mockups, technical feasibility, performance criteria, and empty security considerations. And this can be defined however your development and definition of ready is in the project. But we have this for our example. Okay, but now I'm almost happy with this, and I can also follow from the activities section how and what is done here. Okay, seems like the user story was improved a little bit by GenAI, and also feature branch was created for me. So this is the source code repository for the service, and it already did the feature branch for me, so that all the new changes will go to that feature branch. And yeah, agents will work on that, and as we know, so can humans. So I will create those security requirements by triggering this DPO agent. Yeah. Okay. Pretty soon I will expect to have something here. Okay. Yeah. We got it. Quite a big list. This is not about security, so I will just skip it. These are the, well, you probably all have done a lot of prompting with the LLMs, and they are really capable of kind of doing a lot of things. So we are also using those similar LLMs here behind the background. So, but from the context of agent, right? So they can do a lot of good things to you, and we can optimize those. Okay, now we are happy with this ticket. Now, the second way to trigger agent is by moving the ticket to next column. So now I will select this for development, and now our architect agents will kick in and start doing the implementation specification and test plan and test design. So let's see actually what happens here. And by the way, the agents can also include new labels to tickets so that we can follow better what's is done by agents to this task. For example, here we have a GenAI security and GenAI user story template that was used by PO, and the other one was from DPO, right? Okay. Nothing yet. We can wait a little bit more, and I can refresh this if there's need for that. Yep. Okay, now we have two different swim lanes here. The first swim lane is for the development part, and the second is for the testing and validation. So we have a new subtask for the implementation here. So now we have API endpoints, and this seems like pretty good. stuff to me. And implementation details. Okay, seems like no need for database changes. I'm a little bit surprised. Okay, this now suggests me to implement the file storage way it is. So if I am not happy or this does not align with my kind of software architecture and way of doing things, I can now edit this description as is pretty easily. And I could, for example, change here, do a little bit, instead do the database changes and for example, do not use file storage. But probably this is better to do like this. So I will actually keep it like this more. Yep. All right. But sometimes, as we all know, depending on the temperature of the AI, you can have a different kind of solutions here. But this is the place to kind of review what's going on, what's going to happen, and so on. Okay, I'm pretty happy with it. And then we have a test, learn and acceptance criteria scenarios. These are more detailed in a way that you get a lot of different successful scenarios, but also unsuccessful scenarios. And with the help of these, we can implement end-to-end tests with the test developer agent and, of course, testers, right? Okay, we are happy with these. We move then to in progress. Okay, didn't happen. Yep. And now the developer agents are working. This takes something like a couple of minutes. So maybe I can tell you a little bit about our developer agents. This is our custom implementation. We started this project maybe something like 9 months ago, but nowadays we have really good third-party developer agents. So the most probable way or the best solution you get when you integrate actually third-party developer agents here. I would expect that you can get a really good result out of that. Let's go to the activity. No activity yet for this. Let's see what's happening for the test part. Okay. We can actually open the feature branch where all agents are doing their stuff. And we can see this branch is one commit ahead of main. This is probably the initial. Yeah. No work done yet. Great, take some time. Okay, now we got it. Yeah. All right. No demo effect. Except you kind of have an additional, I can see, additional dependency that needs to be installed. Our developer agent doesn't do that for you. So this is expected. But yeah, our developer agent also includes run step for running tests and so on. So it implements the feature unit test and does some execution. But in this particular case, when I requested this kind of feature, there's requirement for additional dependency. So our agent is not capable of solving that out of the box, but it's about in this case would be developer to kind of check into this feature branch and take control of what's going on. But I would say this is great demonstration. You get a lot of, in a good situation, you get a lot of good implementation already, and you can start reviewing and doing a little bit modification for that and finalize the feature branch and do the typical stuff you will create in the end. Pull request and do your quality assurance stuff, and then your typical CI/CD pipelines will kick in, and eventually you will get this released. All right, if we are happy with it, we would continue with this. But if we are not happy with it, we can always take a task back here, modify it, and then once more here, and we'll get another result, right? And yeah, and if it just doesn't work, then we can kind of have a actual developer do the job and so on. So what I like this is a commonplace. This Jira board would be commonplace to kind of manage agents and actually humans in a single place, right? All right, I think that's about the demo. I did not go too deep into the details of the source code, but I guess it's not the point here. I think we all believe that the developer agents or AI can do really good coding.
So basically what we were kind of like building here is the kind of like this kind of a system where we have multiple different agents interacting with each other and building on top of different integrations to get all the data in. And I think that's one of the key parts as well. And okay, now I'll answer questions. We have Chris Lindbergh saying, do these agents run the risk of replacing junior engineers in the long term? That's a good question. I think the profession of software and junior engineers is going to evolve. I think the question is about the same as do higher level programming languages replace coders? I cannot program in assembly, but I'm still a coder. I cannot program in machine language, but I'm still a coder. You still have a lot of people saying that, for example, that compilers are deterministic, but they really are not. That they really are not nowadays deterministic. So you really don't know what kind of code you are getting out of a compiler when you compile your program. And a lot of the like stuff that we have in programming languages anyway, levels of abstraction over what's actually happening in there. So I'm stipulating that the programmer experience is going to change, and you're going to interact a lot more with the computer in a much more human way than before. Basically, what we've been doing now is just figuring out the way to talk to computers with programming languages. Programming languages are meant for humans to try to understand what the heck is going on the processing side of it. And those are all abstractions figured out by humans. So now we can just kind of skip that step, build on top of LLMs and I'm interested to see what kind of programming languages we have in 10 to 15 years, which are made to figure out what the systems are doing. So I'm superbly interested in what's going to happen there. I think in the short term, there's going to be a problem that everybody's going to think that we can replace junior engineers with these.
Yeah, and the shape of engineering will definitely change in a way. So this is not just about replacing junior engineers, but all engineers in a way. Yeah. A lot of development work will probably, if you consider 10 to 20 years, probably humans don't do that anymore at all.
Okay, Christian Noigard is asking, are these agents shown native to Atlassian, or which framework can you choose to hook them into the Jira board? So I guess, Alex, you can answer that.
Oh, this is, we have implemented this with Llama Index and Llama Deploy. All the agents are independent containers, basically. And you can, of course, put those agents in, deploy those to any kind of container orchestration system. Locally, Kubernetes, we have them running on Kubernetes. So, but in the future, you will have a kind of more and more low code or no code agents platforms in a way that you can start experimenting also with those. But there are some situation where you need to basically have your own custom agents and probably need lower layer kind of implementations in place. So
yeah, and also one thing to say is this is not just limited to Jira. So we are basically using the Jira APIs to just access that data and do the triggers from there. Nothing is preventing us from lifting and shifting this system because it's already living outside of Atlassian. Atlassian is offering their own bots, but they don't do the context as good as what we are building now by ourselves. And then from that, we basically can hook it up into Microsoft's ticketing system, Monday, whatever ticketing system comes into your mind, Parallel, that can be done. Just when you have an API to get to the knowledge, which is the tickets, and you have some triggers, we can basically integrate into. Gurav Hunswakar is, sorry, I'm probably messing up how you're pronouncing your names, that he's how does the LLM decide which programming language to use? This comes from the context that we give it. There's design documents in what we wrote. It can read Jira, it can read what languages are already used and use the same languages and the same kind of definitions. The idea being that is given as a context, hey, we are building this API, here's a list of libraries that we are using, here's the list of languages we are using, and then it's going to use the same. Again, the kind of same discovery process as a junior developer. That okay, here's our documentation, here's our code. Okay, let's figure out what language should I use to build up the next feature, because basically nothing is now stopping you from taking a new language into any project, but it's just a little bit silly. And let me figure out how to access the Q&A panel.
Example, we have defined the technology stack and architecture so that we allow the agents access to that information, right? And that's how they kind of decide what to do.
Okay, we have a question from Simon Sali who's asking. I'll just put on. Let's say, if code of AI agents if an AI agent creates a bug and an AI bug solver agent cannot resolve it, will it then not be hard for a human to try to troubleshoot the bug, since it will be hard to relate to the AI code? Maybe in the future, yes, but now, of course, AI is mimicking the way that humans write code, and it's the same kind of discovery process as any kind of other bug hunting process now. It doesn't really affect your daily work in other ways than fixing because most of 80% of the time is spent trying to figure out what others have written in code. Code is about communication, so it doesn't really change your typical day-to-day if that is written by an AI or a human. And that's why we put a lot of emphasis on unit testing. We put a lot of emphasis on acceptance testing, because that helps you in both cases. It helps you a lot with AI because now you can get stuff done faster. It doesn't change the core process. It just takes it up like 10 times, makes it 10 times faster. Everybody becomes a 10x coder, and maybe the best ones become 100x coders. So you're again going to have this problem of complexity and more code. And you need systems to keep that in check. So you need unit tests, you need testing, you need validation that you're doing the right thing. And this has always been the case for software, and nothing's changed there. You just get it done faster and faster.
Yeah, and you probably want to split huge tasks into smaller ones so that it's much easier to do development. Yeah.
Moktan is asking that, have we deployed this this is deployed now, and that we are running it as well. So it's not just a demo. We've been using it somebody's test, and the difference in terms of benefits or trade-offs. Well, we always have to, of course, depend. We have built the plugins for Jira, so it's easy to deploy to Jira and build on that Atlassian environments. But you could do it in others. Then, of course, you have to build the integrations, and that's always then integration management and access management and all of that. And that's the number one problem with AI is it's not building AI tools. Anybody can create an AI mock in like a week, but actually integrating into a dangerous on in production system and actually doing something in there. That's the problem, and how to do the access, how to make sure that it's doing the right thing and all that. And in the same way as I'm still super scared about big companies just throwing a junior developer and giving me access to everything, because this is pretty much the same thing. You have to have your tests done. You have to have all of that done so you actually can verify what's happening. Demand the same level of verification from humans as you demand now from AI, and it's going to be good.
There's question what data are stored in the RAG database. So basically you put there everything that you need in order to do the development. It can include the Confluence pages, which includes your Scrum processes or whatever processes, and so on. And then when the agents need the information, then they can fetch that from there. But of course, you would probably want to have a kind of retriever or search in a way that the agents can use search tooling. If something is not found on the RAG, you want to make sure that you have a second option to kind of search for the information. So the RAG is not the only way to solve how to put all the required information into the context.
Yeah, now with models starting to have huge context windows, like Gemini now came up with a 1 million token context window, the actual need for RAG is actually getting lower and lower, because you can just feed it into the AI context, because it's 1 million tokens. It's going to be a lot of data that fits in there. So that's also what development loop is happening, and that's also, I think, the interesting part of AI development in this field is that a lot of this stuff is just getting better and better, not like weekly.
Yeah, there's also synonym CAG for that. So it's a context augmented what is generation? Yeah.
Hey, I was Henry. Actually, I think I'm missing Alex, your slides here, but I'm a AI and DevOps guy nowadays, a lead AI consultant, talk a lot about this topic. And if you have any questions about this, please, you can just be in contact with me, or if you want to be in contact with Alex as well, that's also doable. One thing that if you want to learn more about this is you can get our free guide on how to become an AI native software organization, and go to eficode.com/AI native. And there's a guide that we're doing in our company now on talking a lot about the organizational side of this, not too much about the actual physical demo or that, but you can get the kind of that part from there. And we also offer a lot of other services around AI now, being the AI discovery for the first steps, or then on the other deep end, just doing AI platform engineering on how to build these kind of systems that we just showed you inside of your company, inside of your premises, inside of your cloud. So basically everything relating to AI, from just for the AI for leadership demo to platform engineering. So it's been a pleasure having you guys all here. We are now pretty much coming to the end of our time here. So I think we are pretty much done. And if you have any other things in your mind, you can contact us in many of the different places. You can also go into eficode.com, use that, and then just add us on LinkedIn and ask in LinkedIn as well. That can also be done. So I think I'm going to do a last check on chat. Do we have anything else here? Yeah, will the recording be shared? There's one question that I think I can answer. I would like to know how data security is handled here for AG in finance application. Well, it's the same way as in any kind of database security. You just have to make sure that the databases used here are secure and data is partitioned. Typically, the problem is that the data that you start feeding AI is not properly partitioned. It's very difficult to do partitioning, and you end up with the one bucket of basically all company data in there. And that's not acceptable in any kind of environment. If you just have all of the company's knowledge in one database and all of the stuff in there, anybody can cannot speak anymore, access the board's emails and all of that. That doesn't work. You have to have a system of security in place, and that's how do you do that segmenting, and how do you do that? That's the key thing that you have to figure out in your company, and then split the AI agents into the same roles, so that the AI agents will also have security roles to make sure that they can access only the right information. And that's how you do this security partitioning for AI. I think we could talk a full webinar about that as well, but no.
Yeah, that's true.
Okay, hey, then thank you everybody. I think we'll close up this webinar for now, and check out the next part that's just been linked to the chat as well on Top AI Tools webinar series that we have, episode 6. So thank you, so long, and thanks for all the fish.